Welcome back. Last time where we left off, we had a knight in a game. Let's have a quick look. And we were able to rotate the knight, and it plays the correct animation based on where you're facing. Also, the facing relative to the map stays the same even if you rotate the map's viewpoint. So that's nice, but this is just one knight, and today I want to make sure that we can add multiple units on our map. So let's get started. So as a first step, let's make it so that we can have two knights on the screen. And our knight currently has a fixed position, and we keep track of the rotation here in this in the game scene. We could, of course, add another one of these and gives it its own rotation, perhaps a position, but that doesn't sound like it will scale very well. So what we ideally would have is some form of a collection of units, and then make sure we draw each and every one of those units and keep track of them somewhere. So let's start by creating a very simple entity class. So let's create a new Swift file for entity, and units will also be entities. And this one will only keep track of two things. It will keep track of the position, and it will keep track of a rotation. And we will default it to the default rotation. And we need an initializer because this is structured so it doesn't get created automatically, but fortunately we can at least get one here. We don't need this one because we have the default value anyway. So we'll just set a position. And now we can go into our game scene and start refactoring this a bit to keep a list of knights. So let's say we have a list of entities. This is an array, and this has an entity at a position, for instance, 1, 1, 1, and we have another one that's at position 3, 3, 3. And the height we can look up in this height map. So we now have two entities, but we don't have the rotation anymore. So instead of having this hard-coded addition of a knight, what we should do is we should go through each entity and then create a sprite. We can copy paste all this stuff in. Let's rename this one to a sprite because we will want to do more than just knights going forward. For now we can keep this name. The position we no longer need because we have an entity that has a position. This one we can also rename to the entity screen position. And we have the entity.position here as well. And we have the get knight idle animation function. We can use this one so far. The knight rotation. Did we delete this one? No, not yet. Let's get rid of it. And also this one we will get from the entity itself. Okay, so far so good. So these rotate knights no longer work. The easiest solution will just be, let's say we have our entities and we take the first one, and that's the one that we want to rotate using the buttons. And this now, I think all can stay the same for now. So let's see if we now have at least 2 knights on the screen. Okay, so we have 2 knights at different positions. We can still rotate the viewpoint, and we can rotate one of the knights independent of the other one. So that's cool. And let's see if we can also move them around. And what we can do is move one of the knights or run a random knight to a random position just to get an idea about that we can move them around. So let's create a quick helper function to move a knight to a random position. So let's see, we have a function here called move a random entity to a random position. And this one will have an entity. We'll take a random element. We'll take a random x coordinate. We'll do something similar for a y coordinate. And then we have a z coordinate that is the height map y and x. And then we set the entity.position to a vector, a new vector x, y, and z. And then we redraw. To call this function, we will quickly create a button in the content view. So we have a spacer here. Below the spacer and above the other buttons, we'll create a new button called random. And this we'll call scene move random entity to a position. And let's run this. Okay, so they sort of move around. While moving around, they retain their rotation. So this works. So we can now add multiple entities. Well, in particular, multiple knights to the scene. What if we want to have other units as well? And well, we want other units as well. So what we should first do is let's get some other units. So I have these sprites prepared for a rogue, sort of archer, and let's import these one. We call this one rogue, and let's copy paste these one in, drag them in. And now we also have some rogue sprites. So how can we use them? We need some way of making sure that we get the correct sprites, the correct animations. And we have here this function that just returns knight animations, but what if we want rogue animations? And currently there's no way of making a distinction between them. So what I think we should first do is make sure that in our entity, we're also keeping track of the sprite we're talking about. And this one will just be a name. This means that we also need to add it to our constructor. And create a self.sprite. Also, I want to rename this one to start position, because this is something that changes over time in the game. Now we need to go back into our game scene, and we now need to pass in also sprites. So this will be a knight. And here as well. And this will be now called start position. This should still work as before. And it does. mostly because we're still hard coding names for the images for the first sprite and for the animation frames. I think what we want to do is create a function that helps us do this in a better way. And what I want to do is, well, I've looked at multiple ways of solving this, but I think the easiest one is one where we have a function that returns animation names as required, and then have the function, the idle animation function, make sure that we load those and create and transform the animation name, finding the correct images, and creating an animation out of that. And the reason for that is the resulting action here is very difficult to test. You can test them, of course, by playing them and looking at the screen, but it's very difficult to write an automated test to validate them. Whereas it's pretty easy to create a test that validates whether the correct animation name gets passed back. So that's why I'm choosing that solution. That also means that we can go and write our test first. So let's see, create a new section called animation names tests. And our first test will test our get idle animation first frame name. So for an entity, it's a bit of a mouthful when night is passed in. And the reason is this function that we will create in a bit will make sure that you get this name for the when creating the sprites, that you have first frame to show. So let's get started. So let's create some test cases. And these test cases will be built up as follows. There will be an array of tuples, and the tuple will contain a sprite. It will be a string. They will create contain a rotation. And they will create an expected value that we return. So let's get started. So we have as sprite, we will use night because that's what we're passing in. We will create, look at all the rotations, and then what we expect to get back is a night idle 45 0, because it's the first frame. And we want to do this 4 times because we also want to do this for the other rotations. Okay, so that's our test cases. Now let's look through each test case. Let's create an entity based on the test case.sprite name. Start position can be 0, no problem. Our entity will have a rotation that is our test case.rotation. And then we will assert 0 has no member 0. Oh, apparently we didn't create a 0 value when defining vector. We'll fix this in a minute. Let's finish writing the test first. So let's call our function here. So we have get idle animation first frame name for entity, and then we will pass in our entity, and we expect this to be the same as test case.expected. So let's make sure this compiles. First, the start position. So let's go to our vector class, and let's add a static variable called 0 of type vector, and this simply returns a 0 vector. This is always useful to have. So this one should now work correctly. We now have an entity, And now let's create this function. So let's go to our ISO converter and at the button create a new function. This takes in an entity and this returns a string. And for now, let's return an empty string. Okay, let's go back to our test and let's run a test. Okay, so the test fails, of course, because we're just returning an empty string and we're expecting something else. So let's get back to our converter and start filling some stuff in to get it working. So we have our entity here. Let's say we have an animation name. Let's see, what is the least that we can do? I think we can just return our entity.sprite. Then we need the animation name, in this case idle. And then we have our entity.rotation raw value. And we return a 0. So this should work. Now this works if you send the rotation of the entity matches directly the default matches the map in default rotation. What if a map is rotated? So what if we have a similar test that says that when the night is passed in and a map view is rotated. So let's say we have we rotate the map 135 degrees. Then I think this one should return 225, 315, 45, and 135. So they should be rotated 90 degrees. We'll need to check this in a bit. So this means that we need to be able to pass in the map's rotation, and that's not something we have currently. So let's go back to our ISO converter and make sure that we can also enter reference rotation, and this can have the default rotation normally, and then we use a view rotation, and that is the entity.rotation with reference rotation, and instead of entity.rotation, we here use view rotation. And now we need to really return this one. So let's give this a go, see if this test works. It fails, and most likely because I'm rotating the wrong way around. So we can use this one as a cheat sheet. So 45, 135 is 135. And then it's 225, 315, and 45. And let's run the test again. This fails because we're not using the reference rotation here, and we should rotate by 135 degrees. See if this now works. Okay, so the test succeeds. So we have now a function that gets the idle animation first name, and we can use that in the game scene. So instead of image names that is hard coded here, let's say get this animation first name and use our entity entity and the rotation of the map. And this should still work. Now, let's see if we can add a rogue as well. So let's write a test for that. We can use these two tests again. Instead of that, we use when rogue is passed in. Let's run these tests. And these pass directly, but this is actually not what we want, because if we look at our rogue assets, we see that the animation names are made up different. So instead of being called idle, they're called two-handed melee idle for this animation. That's just how the animation was is called in the original model. But our game probably doesn't know that much about how these assets were created, and I would ideally want to use as much the same names like idle on all the places as possible. Now, of course, we could rename all these sprites. However, I think it's easier to simply convert them when creating in this function to create the correct name. So first, let's augment our test to take the real name of this one into account. So this is called two-handed melee idle, and here as well. And let's run our tests. And of course, now these tests fail. However, if we go into our converter, we can create a translation step. And we can do that by creating a sprite animation map. And this is a dictionary that takes in the name of a sprite, for instance, rogue, and then contains a dictionary of translations. So idle, for this one is called two-handed melee idle. And now we need to make sure that we use this one in our function. So let's do animation name is, we'll see if there's a translation in the map. Or idle, and if it isn't, then we just default to idle. And then instead of using idle here directly, we use this animation name. And now the test and all the other ones should pass. Okay, so now they all pass. So now we can get the idle animation first frame for the rogue as well. The next step is I would like to do the same thing for animations. So let's go into our test and create a test to get an idle animation name when the night is passed in. This test is quite similar to the first one, so we can fortunately copy this. And the big difference will be that we now no longer have these frames at the end. And the function name is also a bit different. This doesn't work because this function doesn't yet exist, but we can create it, at least a stub for it. returns a string and an empty string as return value. This of course fails, but we can quickly implement it, and in the most basic form, this is our entity.sprite for our idle animation and rotation. And this test should now pass. Similarly to the other one, we also want to work this correctly if the map view is rotated. So let's copy the second test as well. And now we also need to pass in a reference rotation. So let's go to our converter. Let's pass in a reference rotation. And this should now compile, but the test should still fail because we're not using the rotation. We can use the same code as here for the view rotation and use the view rotation here. Okay, this test now succeeds, and we can do something similar for the for the rogue. So we use this function name. And we get rid of the frames. So this should at least compile. But the test will fail because we're not taking the 200 milli idle into account. So let's go back to our ISO converter and use the same thing as we did for the first animation frame name. And use that one. Okay, now the test succeeds. We can actually refactor this a bit if we say this one is just this function. Oh. With the entity passed in and the reference rotation passed in, plus underscore 0. So test should still pass. And now we refactor this code a bit. Okay, so let's use this animation name in our game scene now. So we were already using the other one. Let's see what we have to do to use it in the game scene. So first off, we have this idle animation function for a night. Let's make it a bit more generic. Let's call it get idle animation for entity, and we pass in an entity. Let's get our animation name. We pass in the entity and our current rotation. And now the frames are let's get rid of all this stuff. Animation name underscore 1, 2, 3, and 4. And the rest can stay the same. So we should use this one now instead of the get night idle animation. And we simply pass in an entity. Let's build. And let's run. So we have these two now, but we can still move around. We can still rotate one of the nights and rotate our map view. Let's add our rogue. So this is a new entity that has a sprite rogue, has a start position of, let's see, for instance, 4, 0, and then a height of 1. So we want it on the edge so we can see it very well. And let's see, so here is our rogue. So if we rotate our view, we can see that the animation, the rogue keeps facing the same direction relative to the map. And all the other stuff still works. So that's cool. So I think that's it for today. So we now have a very simple way of adding multiple entities and showing them on the screen. Next time I want to start working on really moving units around on the map while taking pathfinding into account. So I really want them to take the terrain into account and create real paths to move around. And also I want them to take steps from one tile to another instead of sort of teleporting somewhere. But that will be a multi-step process. We will start working on the pathfinding next time and see how far we get. So thanks for watching and have a good day.